Hi, this is King of Review. Kate wants to make 800 milliliters of an 8% salt solution by mixing two different solutions together. The solutions are 6% and 10% salt solutions. How many milliliters of 6% salt solution does she need? So what we want to do here is make a couple of equations that represent this situation. But before we do that, we need to define what our variables will stand for. So let's let x equal the milliliters of 6% salt solution. The milliliters of 6%. And let's let y equal the milliliters of the 10%. So now, using these variables, let's make a couple of equations. Well, we see here that she wants to make a total of 800 milliliters. So the total volume that she wants is 800 milliliters. So this will consist of the volume of 6% and the volume of the 10%. So if we add the volume of 6%, x, plus the volume of 10%, which is y, this should equal a total of 800 milliliters. So this is our first equation, x plus y equals 800. Now let's take a look at this other piece of information. She wants the final concentration to be 8%. So how do we write 8%? Well, 8% is the same thing as 8 over 100. So she wants a total of 8%. So 8 over 100 times the total volume, which is 800. So 8% times the total volume of 800. And now let's consider these two starting solutions. So we have 6%, which is 6 over 100, times the volume of the 6%, and we're letting that equal x. So we have 6 over 100 times x, plus 10%, that's 10 over 100, times the volume of the 10%. Well, that's y. So we have 10 over 100 times y. Now let's simplify this equation. So we'll still keep 6 over 100 times x plus 10 over 100 times y, but we'll have this equal to, let's simplify this right side. 100 goes into 800 8 times. So we have 8 times 8, which is 64. So here's our second equation. We have two equations. X plus y equals 800, and 6 over 100 times x plus 10 over 100 times y equals 64. These are the two equations in our system. Now we need to solve for x and y. So to do that, we're going to use a method called Cramer's rule. Now, Cramer's rule will use determinants to solve the system of linear equations. So if we have two equations that are in this form, ax plus by equals e, and cx plus dy equals f, we can use Cramer's rule to solve this system. That is, find x and y. And you can see that our two equations here are in this same format. So what does Cramer's rule say? It says that x can be found by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And likewise, y can be found by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So now let's set up our matrices. We'll have three of them. The first one is our coefficient matrix. So the entries in this matrix, well, they're going to be the coefficients of our x and y terms. So A, B, C, D. Now the x matrix The first entries here are E and F. And if you look over here, E and F are the constants of our two linear equations. And then the other entries will be B and D. And then the Y matrix, this is equal to A, C, E, and F. So this is how we will set up our matrices. So let's use our specific values to make our three matrices. Let's first do the coefficient matrix. Well, what are the coefficients? We have a 1, a 6 over 100, and a 10 over 100. So 1, 1, 6 over 100, and 10 over 100. And now let's look at our X matrix. E and F, well, those are the constants. So we have 800 and we have 64. And then we have B and D, so 1 and 10 over 100. And now the Y matrix. We have A and C, so 1 and then 6 over 100. And then the constants, so 864. So now we've set up our three matrices, but you notice when we solve for x and y, we need to find out what the determinants are. What is a determinant? Well, a determinant is a real number associated with a square matrix. So let's say we have the matrix with entries A, B, C, and D. To find the determinant, we're going to take the product of the main diagonal, so AD, minus the product of the entries in the other diagonal, CB. So AD minus CB, this will give you the determinant. So let's find the determinant of our coefficient matrix. Well, the main diagonal, we have 1 times 10 over 100 minus the product of the entries in the other diagonal. So 6 over 100 times 1. So we have 1 times 10 over 100 minus 6 over 100 times 1. And when we work this out, this is equal to 4 over 100. So that's the determinant of the coefficient matrix. Now let's work on the determinant of the X matrix. Well, we take the main diagonal, so we have 800 times 10 over 100. And we subtract the product of the entries on the other diagonal. So 64 and 1. So 800 times 10 over 100 minus 64 times 1. And when you work this out, you get 16. And now let's do the Y matrix. We'll take the main diagonal, so 1 times 64 minus the product of the entries in the other diagonal, 6 over 100 times 800. So we have 1 times 64 minus 6 over 100 times 800, and when we work this out, this is equal to 16. So now solving for x, we have the determinant of the X matrix, that's right here, that's a 16, divided by the determinant of the coefficient matrix. We solved for that. That's 4 over 100. And when you work this out, this is equal to 400. So x equals 400. But what did x represent? Well, we need to look back up here. X was the volume of 6%. So we used 400 milliliters of 6% solution, of the 6% salt solution. And now let's solve for y. The determinant of the Y matrix, we solved for that, that's 16, divided by the determinant of the coefficient matrix, that's 4 over 100, and this equals 400. So y equals 400. Now what did y represent? Well, that's the volume of the 10% salt solution. So 400 milliliters of 10% salt solution. The question asked, how many milliliters of 6% salt solution does she need? So the 6%, that was represented here with X. So she needs 400 milliliters of the 6% salt solution. And that's your final answer. Thanks for watching.